The penultimate, the second last chapter for completion of the syllabus. And that is why I was a bit concerned when I had a few students registering like as late as last week and the week before last. I was quite concerned because we are almost towards the end of the syllabus, and whether you will get your money's worth at such a late stage, unfortunately, you will have to deal with that. That's beyond my control. What was also beyond my control was the scheduling of test 1. We have as yet not received final confirmation from the faculty with regard to access to campus to write your tests. However, I have been given a date, and I'm saying this is the latest date for test 1, and that, if I can confirm, that's the 5th of April, Tuesday the 5th of April. That is the latest date that's been given to me that test 1 could be written. And again, I'm saying latest date because management could give the green light, faculty could give the green light today that you are now allowed on campus. So obviously, test 1 will then be earlier. And that is why, if you can recall in my email and my posting on Moodle, I did say you should be prepared for the test at short notice. So in other words, what I'm trying to say is that if management confirmed today that you are allowed on campus to write the test, and the test could be either this Thursday or next week Tuesday, I will obviously send out a reminder or a notification. So therefore, I'm saying to you that you should be prepared. In fact, your test 1 was scheduled for the 15th of March. That was the first date. And then it was rescheduled for today, the 22nd of March. So you should be already ready and prepared for the test anytime after today. Okay, so that's very briefly on the test 1. So we, as I said, it's beyond my control, but we are all eagerly awaiting feedback from the faculty with regard to access on campus for online assessments. Or not online assessment, but on-campus assessment, face-to-face assessment. Okay, so that brings us, like I said, to chapter 3, traffic studies. Sorry if someone just by show of hand can confirm that you can't see my slide. Chapter 3, traffic studies. Thank you. Okay, so yes, it's the second last chapter. So you can see we've almost to the end of our syllabus. Traffic studies. So if you look at the introduction of traffic studies, what we are really looking at here, examining some of the basic traffic engineering studies, and the whole idea here is to gather facts. So the whole purpose of this is to gather facts on traffic conditions and parking conditions and so forth. And it is very important for you to gather information that is accurate, unbiased, so that in your design you don't come short or fall short. And you will find that there are various types of traffic surveys that we have conducted over the years, and many of this has not changed, except for maybe some modern equipment that is now available that may have made life a little easier, in terms of the methodology adopted. And we will look at some of those aspects. So in terms of inventory, what do we mean by inventory? It's simply an accounting, or it could be a tabulation, or it could be a graphical display, whatever, a listing of information describing your existing conditions. Okay, and these inventories, like traffic conditions, parking facilities, public transport routes, and so forth, will require upgrading or updating from time to time. They could change. Compared to maybe street width, may require less change But when it comes to parking regulations, traffic regulations, public transport routes and so forth, these may change more often, and therefore from time to time, maybe every 3 years, 4 years, 5 years, you will need to update your inventory. So I'm referring you then to page 1 of your notes, and on page 1 of your note, you will see the various inventories listed there, like on the top of your slide. So you need to go on to page 1 and look at these various inventories that's listed there. For example, and I'm not going to labor it, but if you look at admin, environmental, geometrics, you will see that that deals with inventories of public streets, highways, roadways, your shoulder, your sidewalk, and so forth. If you look at traffic generators, and that deals with inventories of maybe office complexes, shopping malls, residential developments, schools, and so forth. And if you take the next one, regulation and standards, then that could deal with, for example, geometric standards, parking supply, traffic control devices, as the word suggests, dealing with traffic signs, signals, pavement markings. So all that will be covered under traffic control devices. So you can go through each one, and there's a short paragraph on each one. Transit facilities, we're looking at public transport facilities, okay? Parking, passenger pickup points, drop-off zones. So that will all be covered under transit facilities. Parking facilities, again, very self-explanatory, whether you're dealing with on-street parking, off-street parking, your existing parking supply, the time limit to park, okay, whether you have parking meter controls, special zones for taxis, for passenger loading. So all that will then come under the parking facilities. And then with storage of inventories, you will see at the bottom of page 2 that there are many types of inventories, and you've got those bullets there giving you all the examples of inventories. And again, I'm not going to go through each one. For example, one-way street, looking at weight limits of trucks, overhead structure clearance, which is very important, because at the end of the day, if you are carrying an abnormal load on a truck and you don't check height clearance of bridges, you could end up scoring the bottom of the bridge, and you see that often on the road. Don't do your homework and don't check the special regulations. Don't check, for example, what is the overhead structure clearance and so forth. Speed limits. So all these then are typical examples. And there are a few more that's on the top of this slide: off-street parking facilities, roadway widths, so curb parking regulations. And these inventories then, in the past, most of them were stored on manual card files, okay, for storing the data. But now with modern equipment like computers, they are now stored on computer files. And one must also then try and separate your inventory. So in other words, have separate files for intersections, for highways, for storing of your information. Okay. So, and again, you can see at the bottom of this slide some information on updating your inventory records, which I mentioned a short while ago. So you can see some of the information needs regular maintenance, periodic maintenance, and you will see at the bottom of the slide 3 to 5 year intervals may be required. So it's more the inventories that you would expect to change from time to time. And certainly volume studies is important for any traffic engineer. I think the other day, and you did this in 2A as well, how to determine or how to obtain, how to conduct volume studies. So what is very important then is to have some data on volume studies, then no data. No data, like I said, you can design a facility, and the moment it's open to traffic, could be running at capacity, systems failure. So therefore, volume counts are very important to establish your existing traffic flow conditions, and that's important for planning and design of a new facility or improvements, upgrade of an existing facility, and the various time intervals one could use for traffic volume counts. And you can see right from 15 minutes all the way to a week. You could even do ADT, annual average daily traffic, or average daily traffic. And basically, the shorter periods are quite important for design purposes. You know that your traffic volume changes over a shorter period. Okay, so therefore you find that your shorter time intervals are quite important. And there's various ways one could collect the information. How can one do volume counts? Yes, and again, this is not new information to you. You've done this in 2A by manual methods or automatic methods, and they both have their advantages and disadvantages. One of the main advantages of the manual method is that you can do classification. Classification meaning you can classify your vehicle. So you there counting on the road, you can see whether it's a private motor car, whether it's a truck, whether it's a bus, whether it's a motorcycle. So classification of, and you can also count the number of occupants in the vehicle, the direction, whether it's going straight ahead if you're at an intersection, whether it's right turning, left turning. So the movements can also be classified. So the number of uses why we conduct these volume studies, and some of them are listed on the slide. Measurement of current traffic. And you could also do these volume studies in conjunction with your OD surveys. And again, I'm not going to labor OD surveys, origin destination surveys. You've done a few methods: roadside interview method, postcard method, home interview method, colored disco tag method. So you've done various types of OD surveys. Also, in terms of your EVU rating, how you classify highway traffic, and you've done typical examples of EVU rating, where you worked out the percentage of heavies that you converted to PCUs or EVUs, equivalent vehicular units or passenger car units, by multiplying by the appropriate factor, depending on the number of lanes, depending on the road, whether it's a level road, a rolling terrain, or mountainous terrain. So you've done typical calculations. Determination of capacity also from your volume studies. You all know capacity, maximum number of vehicles passing a point, given time. Level of service, yes, your level of service also is linked to your capacity, linked to your time of day level of service, or whether you're under normal flow conditions. So you may recall capacity under prevailing traffic conditions or prevailing road conditions, prevailing traffic conditions, how your traffic varies from hour to hour. So you could get traffic under normal flow conditions where you got free speed, opportunity to overtake. So in terms of level of service, you're looking at more level of service A or B. And then as your traffic approaches unstable conditions, where there's vehicles moving at a fairly reasonable speed, but the concentration is on the vehicle in front of you. So you're looking at, although you're achieving high volume flow, you are under unstable conditions, and one error in a traffic like that could result in a traffic jam situation. So you've gone right down to forced flow conditions. And again, your level of service then from A, B, the highest, can then unstable flow move to C, D, and then to forced flow conditions move to E and F. So that's how you could depict the level of service. So there's various, as I said, uses for volume studies, and you can see the others listed in terms of highway economic studies, establishing geometric design criteria for a road, okay? What super elevation to apply, your horizontal alignment, your grade. That's your vertical alignment, your vertical curves, your grade, or your horizontal alignment, your side distance, your horizontal curves, your transition curves. establishing parking demand from your volume study. So various uses, and it's all listed here on the slide. So capacity, a little more information on capacity, then you can see the capacity here. If one looks again in general, capacity defined as the maximum hourly rate at which persons, vehicles, passenger cars can be expected to traverse a point. And very often we use X vehicles per hour. Very often we equate it to, but remember, it can be over a shorter time period, like mentioned here, capacity analysis in 15 minutes. So the time period can vary. And again, some repetition in terms of capacity, like I said, defined for prevailing roadway and traffic conditions, for control conditions, and brief information on each one is given in your notes and on the slide. When we talk in terms of roadway conditions, we're referring to, for example, the number of lanes, the lane width, the shoulder width, any lateral clearances, horizontal, vertical alignments, all that comes under your roadway conditions. How sharp are your curves? How flat or steep are your grades and so forth? So your side distance, all that comes under your roadway conditions. In terms of traffic conditions, again, like I said, it depends on your traffic stream, and this varies from hour to hour. We spoke about the normal flow, unstable flow, and forced flow conditions. And I think there is a graph in the next slide that you can make reference to. Control conditions generally deals with your devices, your traffic devices, regulations like your signalized intersections, the type of intersection you have, whether it's signalized, whether it's stop condition, whether it's yield condition. If it's signalized, the timing of your signal, the effective green time on each approach, priority turning, and so forth. All that comes under control conditions. So this is just for additional information taken from the highway capacity manual, typical capacities for different freeways depending on the number of lanes. You also have ideal capacity, and you may have come across ideal capacity. When we talk in terms of ideal capacity, what is the maximum number of vehicles passing a point given time under ideal conditions? So what could be the ideal condition? Okay, it could be 2, 3, 4 lanes in each direction, could be good lane width, full shoulder, in other words, full shoulder equivalent to a lane. So if a vehicle breaks down, it could get onto the shoulder and not obstruct traffic on your carriageway. Minimum heavies. So the moment you reduce or eliminate heavies, you're looking at passenger cars all traveling at the same speed, so you can achieve high capacities. Reducing your number of intersections. You know your intersections are your capacity inhibitors. They reduce your capacity. So these are ideal conditions, but not often one can achieve or have these ideal conditions, and therefore we then need to resort to prevailing conditions, prevailing road conditions, prevailing traffic conditions. And when we talk in terms of prevailing road conditions, you know, we spoke about the lane width. If you have very narrow lanes, then a two-lane road, vehicles approaching may cause medial traffic friction with vehicles in the opposite direction, which will tend to automatically result in the driver slowing down. And by slowing down, what happens? You reduce your capacity. Narrow shoulders, a lack of shoulders. Vehicle breaking down then ends up stationary on the carriageway. Other vehicles now will have to take their chances overtaking that stationary vehicle at the expense of oncoming traffic. So you've reduced your capacity again. So all that, those billboards very close to the edge of the roadway, potholes. So you can see all these fall under geometric restrictions, poor sight distance, steep grades. All these fall under prevailing traffic conditions, prevailing road conditions, and how they can have an impact on your capacity. So, okay, that's again from your highway capacity manual. Yes, I spoke about level of service, and I did say level of service is simply a qualitative measure. So in terms and factors that impact on your level of service, like your speed, your travel time, the freedom to maneuver, the freedom to overtake slower moving vehicles, comfort, convenience, safety. So those are all factors that impact on your level of service. And generally, we have 6 levels of service, from A being the highest level of service down to level of service F being the worst. And again, one could then relate this or refer to your level of service on the graph that I was referring to, and that's a graph that I was referring to. So you can see a typical speed flow graph. Speed flow graph based on a quadratic equation, speed flow graph, and you can see with speed increasing, your flow increasing. So right on the top there, that's where you have your free flow condition, normal flow condition, where maybe 2-3 lanes in each direction, vehicles have the freedom to increase speed and also the opportunity to overtake slower moving vehicles, and generally your level of service A and B falls in the free flow zone. And then you can see you come to this point, the unstable flow zone. So you can see, although you're achieving fairly high flows, Q is your flow, at a reasonable speed, the condition is very unstable, meaning you as a driver, you are watching the vehicle in front of you. The vehicle in front of you is watching the vehicle in front of him or her. So there's tight concentration, very short distances. So when we talk in terms of the headway between vehicles, but achieving good flow rates. And all you need, like I said the other day, a winter granny to be in that traffic, going to do her Pick n Pay shopping, and she needs to then step on her brake, and there's a ripple effect. All the vehicles then brake. You could end up in a rear end collision or a traffic jam situation, and you could end up in zero speed, zero flow at that point. So there you're now looking at your unstable force flow conditions. That's generally where your level of service E and F falls under. Okay, so you can relate this to your level of service. So in your notes, you have some information relating to spot speed studies and various methods of measurement. So when we talk in terms of speed characteristics, there's various applications, and you can see some of the applications listed on this slide, like, for example, establishing speed restriction zones. That will help you in timing your traffic signals, how much of green time to give to each approach, priority right turning, and so forth. And if you have complaints on speeding, then you can do a check on that. And in terms of enforcement, setting out or determining your speed limit for accident analysis. So there's various applications, spot speed studies. Methods of measurement, how do we measure speed, spot speeds? If I can quickly refer you then to your notes so that you have a reference. So, okay, if I can find it in your notes. Yes, it's somewhere along spot speed studies. Yes, we're looking at page 10, so you can make a note of it. Page 10, you have the methods of measurement. I've just highlighted the methods here, but you could go on to page 10 and read the brief, the paragraph there on each of these methods of measurement. So very quickly or very briefly, we look at direct timing. Direct timing is simply establishing two reference points. So you got reference point A and B. So the moment the vehicle passes reference point A, you record. So you have a stopwatch, you record the time. Passes reference point B, you record the time. And the reference point A and B is a predetermined distance, so you know the distance. So you know the distance from A to B. and you've recorded the time it took vehicle to pass point A and then point B. So you have your difference in time, your delta T, and from distance and time you can then determine the speed. So that is how you would determine spot speed, by means of direct timing. And then the second one mentioned is pressure contact strip. Now, previously, this was used quite a lot for speed trapping, more in residential areas. So maybe some of you are as old as me, then you would have hit one of these pressure contact strips. They're basically rubber pneumatic tubes that's run across the road. And again, there's two of these tubes that are placed across the road, predetermined distance, tube 1 and tube 2. So you have the distance. And as your vehicle hits the first tube, it records the time. The vehicle hits the second tube, it records the time. So again, you have your delta T. And as I said, these two pneumatic tubes are predetermined distance apart. So you have the distance, and one could work out the speed of the vehicle. So generally, you do hardly see much of them today, but in the past, like I said, in many residential areas where the speed limit was either 40 or 60 kilometers per hour, 40 kilometers more around school vicinities, other areas maybe 60 kilometers per hour, and you are traveling at 80 and you hit these pressure contact strips, then not far from where you hit the tube, you'll find the traffic officer pulling you over, giving you a speed fine. And then more on the expressway, freeway, highway, rural road situations, speed traffic was speed enforcement, use of radar speed meters. So that also is another method based on what we call the Doppler effect, based on determining the speed of a vehicle. So they have the traffic officer will have one of these radar devices and aim it at your vehicle. So it's based on the principle of radio wave, bounces on your vehicle and hits back and records the speed. And again, from there, if you're above the speed limit, you'll be pulled off and given a fine. So it's another method. With the radar speed meter, it's quite an easy system to use. Very mobile, so it's a mobility advantage, freedom from vehicle damage. So it's a good method, but sometimes there have been cases in the past where the radar system did not give accurate values, and motorists that were caught speeding did take the department to court in terms. So these radar systems have to be calibrated from time to time to check that they are working properly. So you could have, and also another disadvantage with the radar system is the cost. It has a fairly high capital cost compared to, for example, the previous one, the pressure contact strip that we were referring to. And then the last one you have there is the time-lapse camera. So basically you have a camera and you take an individual picture of a stream of traffic. And maybe immediately after that, after 1 or 2 seconds, you take another snapshot photo of that stream of traffic. So from those two photographs, and these photos have gradations on them, gradations, frames. So you can check from photo 1 and photo 2 how far vehicle 1 moved, how far vehicle 2 moved, and so forth. And from there, one could then work out what is the average speed of that stream of traffic. So simply meaning that if vehicle 1 from photo 1 and photo 2 moved a distance of 20.5 meters in 2.3 seconds, and you did the same, worked out for vehicle 2, vehicle 3, you did a summation of the time, summation of the distance each vehicle traveled, and you know distance over time, then will give you your speed. And perhaps we look at a calculation or so relating to that. So that brings you in terms of time-lapse camera. Also can have fairly high capital cost to purchase these special cameras to do that. And so those then are a few of the methods of measurement in terms of spot speed. Then you have some information on travel time information, and if I can refer you to your notes, in travel time information is on page 14. So you can go to page 14 in your notes and have a look at the several techniques that can be used to obtain travel time information. Perhaps some of these you may have covered at 2A as well. You may have covered some of these. And there's various techniques, and there's 4 listed in your notes. First one being the registration number method. So the registration number method, again, in your survey zone, you have your survey point A and survey point B. So as your vehicle passes survey point A in your survey zone, you record the registration number and the time. And then when the vehicle passes point B, again, you record the registration number and the time. So you do this over a period. And then maybe at the end of the day, over a pint of beer, you can sit and look at the registration numbers of point A and B and the time. And from the time, then that gives you the time it took the vehicle to pass through point A and B. Yes, it can become a bit biased, can lead to some bias. You could get a vehicle that may take a side route somewhere between point A and B. So obviously you're not going to get the full data of that vehicle, but it gives you some information in terms of vehicle travel and the travel time. The other one that we have is the elevated observer method. And here you'll find that as an observer, you are stationed at a high position, where you can see then the length of roadway. And from this high position, you can observe a vehicle passing point A and B on the roadway. And again, you can record the time. So it's another very good method of determining travel time, but it does have its drawbacks as well, and mainly to try and find a suitable position, a high position from where you can record the time vehicle passes point A to point B. And sometimes you will find that, like I said, expense can creep in, where you then need to engage the services of an aircraft to get up on the air to try and observe that stream of traffic. So it can become quite expensive. Interview methods, similar to any interview method, where you go to private companies, depending on the survey area, private householders, get information from the householders in terms of their travel time information, where they're going from home origin to destination. So it's similar to census, but generally you will work on a representative sample. Depending on the size of the survey zone, it may not be feasible to interview every householder. So you take a sample, you do a representative sample, maybe 10 to 15% of the household. Unlike census, you probably heard that the Stats South Africa is embarking on census 2022. The last census was done, I think, in 2016. It was meant to be done every 5 years. It's a major exercise by Stats South Africa, where they interview every householder. Various information that's picked up in terms of employment, in terms of car ownership, number of occupants in the house, salary range. So there's various information that one obtains from census. It's similar, but like I said, based on a representative sample. And then finally, the last travel time information technique that one uses, what we refer to as the moving observer method. No, that's on page 15 in your notes. So moving observer methods, to explain it to you very simply, you have your test vehicle. So your observers are in this test vehicle, and this test vehicle then is driven through the stream of traffic that you're observing. So that length of observation length is obviously predetermined. So let's say it was over a kilometer distance. So this test vehicle is then driven over that 1 kilometer section of road at an average speed. Average speed could be maybe slightly below the maximum speed. So at a reasonable average speed that you would expect vehicles to be generally traveling. And what the observers do, they then record the number of slower vehicles that they overtake. So there may be other vehicles in the traffic stream traveling at a much slower speed. So you record the number of slower vehicles that you've overtaken. At the same time, there may be other vehicles that's traveling at a higher speed than the observation vehicle, okay, the test vehicle. So you then record the number of vehicles that passes you. So if you are the observer now in the test vehicle, then you also record the number of vehicles met in the opposite direction. And then finally, you record the time for you to cover that test section. We said 1 kilometer test section. Depends in any question that will be specified, the length of the test section. So you do that in the direction flow of traffic, we'll call that flow I, and then you repeat that in the opposite direction, flow J. And you do exactly the same thing in the opposite direction, flow J. You record the number of slower vehicles you overtook, the number of faster vehicles that overtook you, the vehicles that you met in the opposite direction, and the time it took you to travel that 1 kilometer, the test section. And from there, you can then determine, using the moving observer method, you can then determine the flow rate, the average flow rate of that stream of traffic, as well as the average speed, space mean speed over a distance. Okay, so that's a typical example of a moving observer method calculation. So you're given the data. So that's direction I in the flow of the traffic, direction J in the opposite direction. And there you can see you've recorded your run. So run 1 in direction I, then you came in the opposite direction, run 2, run 3 back in direction I, run 4 in the opposite direction J, run 5 direction I, and then finally run 6 in direction J. So you had 6 runs, 1, 2, 3, 4, 5, 6, your test vehicle. With the flow of traffic, against the flow of traffic, with the flow of traffic, against the flow of traffic, and so forth. And there you recorded then the vehicles that passed you, the faster vehicle. And the symbol we use is FI, faster vehicle. And like I said, you were traveling at an average speed and there were slower vehicles in the traffic stream which you overtook, and you recorded the slower vehicles, that's your SI. And then you also recorded the vehicles that you met in the opposite direction. So opposite is J, and that's NJ. The J may not be very clear, but that's NJ there. And then finally, the time it took you to cover that length of test section in seconds, the time in seconds is recorded there. So you did that for direction I, you did the same for direction J. That direction J should be somewhere there. So in direction J, again, you recorded the faster vehicles, FJ, the slower vehicles, SJ, the vehicles you met in the opposite direction, NI. The I is not too clear there, so that's NI. And then finally, the time to travel the length of your test section in seconds is recorded there. So that's how the data would be presented. So you're dealing with GA4 here, EXA's graduate attribute 4, which deals with data analysis. So you are presented with that data and you now want to analyze that data. So you're given the length of the test section, 3 kilometers, and you want to firstly calculate the flow, QI, that's in your I direction, as well as the average speed, which we refer to as the space mean speed. And also for direction J now, you want to calculate the flow in direction J, Qj, as well as the space mean speed, SMSJ. So that's how a typical question could be phrased. So how do you go about analyzing or solving the problem? So the first thing you would do then, that's all the information that was given to you. Okay. Here you can see it's much clearer here, the NJ and the NI. So step one, you would add an additional column. Okay. You would just, you don't have to draw the whole diagram, maybe just have a column like that. One row with your number of columns. Obviously you will need, but those descriptions so you know what you're dealing with. So step one is simply to calculate the mean. All we're doing there, we're calculating the mean. So we're taking 4 plus 3 plus 5, which is 12. 12 divided by 3. You could have written 4 there. 12 divided by 3 is 4. So your mean is 4. Same for your slower vehicles, 3 plus 4 plus 4, which is 11. 11 divided by 3. And you could have written the value, whatever 11 divided by 3 is, you could have put the value down there to accurate to 3 decimals. Remember, we working to 3 decimals. Don't forget that. Same for your number of vehicles in the opposite direction. 43 plus 38 plus 43 divided by 3 should give you 41.333. And you can go ahead and do exactly the same. Your time, 115 plus 108 plus 105 divided by 3 gives you 109.333. And you could do exactly the same for direction J. I'll give you a minute quickly just to check that these values are correct. So just punch them into your calculators and check if they are correct. Give you a minute just to verify those values. Like I said, there you could have written the actual, my calculator. Okay, so there you had 11 divided by 3, which gives us 3,667. So you could have recorded 3,667 there, the average for your slower vehicles. Okay, let's move on then to the calculation. And like I said again, a data sheet will be provided for test 2 and the final exam, but if these formulas or formula are not given, then obviously you will need to know them. So you need to get familiar with the data sheet. It is posted on Moodle. So the formula then for Q then is given by Ni plus Fi minus Si divided by the sum of your Ti and Tj, your time. Okay. So what is Ni? Remember, it's a vehicle in your opposite direction. So Ni, there's your Ni. So make sure you're taking the correct value. Ni, which is 32, plus Fi, there's your Fi, direction I now, which is 12 over 3, minus Si, which is 11 over 3, and all that divided by the sum of your Ti and Tj. So Ti was 109.333, Tj was 123.333. Remember, you want your flow in vehicles per hour. This will give you seconds because your time there is in seconds. So divided by 3600 will give you in hours, your time in hours. That gives you average flow rate of that stream of traffic that you observed using the moving observer method to be 500.288 vehicles per hour, 3 decimals. Okay, so you've calculated QI. Now you want to calculate the mean speed, SMSI. To calculate the mean speed, you first need to calculate the mean travel time. And the mean travel time is given by the formula Ti minus, in brackets, Fi minus Si divided by Qi. So Ti, there you know Ti is 109.333. Okay. Again, it's in seconds, so you need to convert it in hours because your flow, you calculate it in vehicles per hour. So you got your time there in hours minus there minus Fi. Fi was 12 over 3 minus Si, which was 11 over 3, divided by Qi, which you have just calculated to be 500.288. 500.288. So you've converted that to hours, so that will give you your mean travel time in hours, which works out to be 0.0297. Just trying to keep to 3 significant digits. 0.0297. So therefore, from there you can now calculate your average speed or your space mean speed, SMSI, which is the length of your test section divided by your mean travel time that you have just calculated. If you go back to the question did give you the length of your test section, 3 kilometers. There's your 3 kilometers divided by your mean travel time, 0.0297 hours, will give you a speed in kilometers per hour. So what that tells you is that the average speed of that stream of traffic that you observed is 101.010 kilometers per hour. Okay? Direction I. Do exactly the same for direction J. So we're now calculating the flow Qj and the space mean speed SMSJ, direction J. Exactly the same, just make sure you're using the correct values. Now it's NJ. If you go back, NJ is 41.333. So there's your 41.333. FJ and SJ. FJ 13 over 3, SJ 11 over 3, 13 over 3, 11 over 3, and there's a summation of your TI and TJ. Again, don't forget to convert seconds to hours, and that gives you an average flow in direction J, 649.853 vehicles per hour. Okay. Once again, calculating the mean travel time, apply application of formula. You have your TJ, check the table given, FJ, SJ, and your QJ that you have just calculated, 649.853. Again, don't forget to convert your time to hours, and that gives you a mean travel time of 0.0312 hours. And finally, to calculate your average speed or your space mean speed, the length of your test section, which was given 3 kilometers, divided by your mean travel time, 0.0312 hours, gives you average speed of 96.154 kilometers per hour in direction J. Okay, so that's a typical moving observer calculation. I'm just going to give you a minute or two for you to do a quick audit to get familiar with the calculation. So take out your calculators, check whether the values we arrived at here are correct. So do a quick audit, give you a minute or two. All right, I trust you are coming up with the expected answers. Then you could do the same for direction J. Do a quick audit and verify the answers. Okay, you should be done with that, and I trust that you did come up with the expected answers. All right, let's move on. Now it's time for your mock test. So if you've done the audit and come up with the correct answers, then you should come up also with the correct answers in your mock test. So you can get out your writing material, your pens, your calculators. And this one is for you to do. You can see the reference on the top. It was a question 4 on the test. Just unfortunately, bear with these columns, as I said, because of the narrow columns, these writings got a bit skewed, but generally you know what we're looking at. We, like the previous example, you had your runs, you had your faster vehicles, FI there, you had your slower vehicles, SI, you had your vehicles in the opposite direction, NJ, you had your time, TI there, and similarly in direction J, you had the faster vehicles, FJ, the slower vehicles, SJ, vehicles in your opposite directions, NI, okay? And then finally your time to run on the test section, TJ. So exactly the same, just figures have changed. Length of test section here was given 2.6 kilometers. And once again, you're required to calculate the flow, QI, as well as the space mean speed, SMSI. And then finally to calculate the flow, QJ, and the space mean speed, SMSJ. So very similar to the previous example. You should know the format now, how to go about doing it. I'll give you about 15 minutes, should be maximum. You should be able to complete that one. So your time starts now. Okay, that's my buzzer went, which means your time's up, so you can get out your marking pens. Doesn't have to be a red pen. And mark your work and see how you fared. Okay, so the first thing you should be checking then is your mean. So even if you worked out the value, 13/3 is good enough. 4, that was 43. That was 108.667. 4.667, that was 3.333. 32.667. And then finally 122.667. So check your mean values there. And then moving on to direction I, your Q, insert your values, NI, FI, SI, the summation of your TI and TJ. Don't forget to divide by 3600, convert it to hours. And that gives you a flow rate, average flow rate of 513.548 vehicles per hour. You may get a slight variation depending on your rounding, but you should be very close to that. 513.548 vehicles per hour. Then your mean travel time. Okay, again, application of formula. Don't forget to convert your seconds to hours. Your FI, SI divided by a flow that you've just calculated, 513.548. That gives you then an average or a mean travel time of 0.0295 hours. And then finally your space mean speed, SMSI, length of your test section, which was given 2.6 kilometers, divided by your mean travel time that you've just calculated, would be 0.0295, and that gives you a space mean speed in direction I equal to 88.136 kilometers per hour. And then finally in direction J, don't forget that don't mess up with your NJ and NI. Okay. Your vehicles in the opposite direction multiplied by your FI minus SI. Okay. Divided by the sum of your time, TI, TJ. Again, don't forget to convert to hours. And that gives you the flow rate in direction J, QJ equal to 689.922 vehicles per hour. And then moving on to your mean travel time. Mean travel time. Application of formula. Again, converting from seconds to hours. FJ and your SJ divided by your QJ, which you calculated to be 689.922. And that gives you a mean travel time of 0.0321 hours. And then finally calculating your space mean speed, SMSJ, length of your test section 2.6 kilometers, divided by your mean travel time 0.0321 hours. And that gives you an SMSJ in direction J, space mean speed 80.997 kilometers per hour. So pretty straight calculations, simple application of formula. Quickly, by show of hands, how many of you cracked that one? Got that correct? Show of hands. None of you. All right. Being honest, but I'm sure you are familiar with the calculations. So that brings us in to the end of module 3. So the balance of this period to lecture is not a free period. You now will need to log on to Moodle and look at the tutorial on moving observer method that's posted on Moodle. And you will then work on that tutorial for the balance of this period. So, and again, I'm saying try and work through it out first on your own and then check your answers. Okay, so that's for the balance of this lecture. And then we will meet on Thursday. But again, as I'm saying to you, is that be on standby. Like I said, as soon as we get the green light from the faculty, your test one will be scheduled at short notice. So be prepared for it. Failing which, it will definitely take place on the 5th of April. But that date is not negotiable. But like again, I'm saying to you that if faculty confirms access to campus earlier, then the test could be scheduled earlier than the 5th of April. So be on guard. Watch out for the postman giving you the final date. And I've mentioned to you previously as well, even if you break a leg, it's still worth your while wheeling yourself to the test venue, because test one only covers transport systems and transportation planning. And the scheduled test, if you go back previous stats, the pass rate has always been more than 80%. Special test pass rate has been in the region of between 5 and 10%, because your special test now covers everything and it's written towards the end of the semester just before your final exam. So you're under pressure with your final exam, you're now trying to write a special test. So it certainly would be in your best interest then to write the scheduled test one. Okay, thank you. Then, as I said, it's not a free period. The balance of this lecture, you should log on to Moodle and tackle the moving observer calculation tutorial that's there. That should bring you on par then with module 3. That leaves us with just one module on density, flow, speed relationship. So you can see we've done quite well. We will have sufficient time for a quick revision. And then, of course, the ball will be in your court for your revision to get ready for the final exam. Of course, before the final exam will come test 2. So remember what we've been doing now in traffic engineering, modules 1, 2, 3, and then when we complete module 4, that's what will be covered in your test 2, which will test your EXA's graduate attribute GA4. All right, I think I've said enough for today then. Please log on to Moodle and work on the moving observer tutorial that's posted on Moodle. Thank you, cheers. I will then see you on Thursday.